These are the Algebra 1 11.4 notes. So what we're looking at here on example 1, it says this is an infinite geometric series. And it's a series because it's adding, and it's geometric because if we look at the common ratio every time, it's being multiplied by a common ratio of 1/4. So that's why it's geometric. So, and it is infinite because this ... means it goes on forever. So it wants to know the partial sums for when n is 1, 2, 3, 4, and 5. So these are actually really easy to find. So when it wants to know the sum of 1, it means the first term. Well, the first term is 1/2, so literally it equals 0.5. The sum of the first two, S2, just means add the first two terms. So that's 1/2 plus 1/8. Then just do it in your calculator. It's 0.625. S3 just means the sum of the first three terms, so 1/2 plus 1/8 plus 1/32. And in my calculator, this goes on quite a bit, so I'm just going to round it off to 0.656. So S4 is the sum of the first four terms, so 1/2 plus 1/8 plus 1/32, plus the fourth term is 1/128, which again, let's just round it off to 0.664. And then let's add the fifth term onto this. So we have the 1/2 plus the 1/8 plus the 1/32 plus the 1/128 plus the 1/512. And once again, let's just round it off, 0.666. Okay, so that's the sum of the first 5 terms. So they also asked us to go ahead and graph these sums. So all they want us to do here is like the x value is in. It means the sum of the first two, 3, 4, and 5. And we found that they were 0.5, 0.625, 0.656. Just writing these down real quick. Okay, so when we go to write these down, so the x-axis down here is just our in values. I'm just going to put 1, 2, 3, 4, 5. And then the y-axis are what the partial sums were. Partial sums just mean we only added up a few of them, not all the way to infinity. So these went up to 0.66, so I think I'm going to go by tenths. So 0.2, 0.3, 4, this will be 0.5, 0.6, this will be 0.7. All right, so if we graph these, at 1, it was at 0.5, that's right here. At 2 is at 0.625. That is about here. All right, 0.656 gets a little bit, about halfway. All right, 0.664 is just a little bit higher. And you can see what they're kind of trying to show us is as the sum is growing right here, but then it kind of levels off. And so what's happening is if you added the next number, which would be, let's see here, 1/2048, you're adding such a small decimal that you're barely changing it. So essentially, it's approaching a sum right here. And this is kind of the foundation of calculus. So if you're going to pre-calculus next year, this is going to be very helpful. So it is approaching this number, which I'm thinking is about 0.6 repeating, which is 2/3. So it says, describe what happens to the partial sum as n increases. So the partial sum, Sn, approaches 2/3. I think if we kept going, it'd get closer and closer and closer to 0.666 repeating. All right, so I'm going to be a little more clear on the sum formula. Let's put an actual name. I think it helps me know when to use it. So I'm going to put sum of an infinite geometric series. So this works when it's geometric, you're adding, and it's going to infinity. Now, there is kind of a limitation on it that I'm going to show you. So you take the first term, divide it by 1 minus r, which is the common ratio. Now, this only works if the positive r value is less than 1, okay? If the positive r value is greater than or equal to 1, then what that means is the sum does not exist. All right, so that would be very important to note. If the r value, and you always take the positive version of it, is greater than or equal to 1, the sum does not exist. This formula only works if the r value is less than 1. All right, so looking here, I can tell the formula is right to use here because I see it's a sum, it goes to infinity, and this is a geometric sequence. So the first thing I'm going to do is I'm going to check the R value. This is the R value right here. It is less than 1, so that means I can use this formula. So for this formula, I need the R value. I also need the first term, which remember, you just plug in 1. And so I type that in a calculator, and I get the first term is 3. So my formula, I take the first term, which is 3, over 1 minus the R value. And you can literally just do that in a calculator, and you get 10. So if you kept up this series and added up numbers and go on and on and on, it will eventually approach 10. Okay, so look at this one, and I see the first term is 1. Now, I do believe it's a geometric series because it looks like the pattern is it times by 3 every time. So it does have a common ratio. So the R value is 3. But because the R value is greater than or equal to 1, the sum does not exist. So that's why the sum does not exist, because that R value, when you take the positive version of it, has to be less than 1. Okay, looking at this one, I also think the first term is 1. So now I'm looking for the R value. It's changing signs. That's totally fine. I think it multiplies by negative 3/4 because 1 times negative 3/4 is negative 3/4. Times again, you get positive 9/16. Times again, you get negative 27 over 64. So the R value is negative 3/4. So this sum will work because when you take negative 3/4 as the absolute value, it is less than 1. So I can find the sum. So I'm going to do my formula. My formula is the first term over 1 minus the R value is negative 3/4. All right, so when you do 1 minus negative 3/4, I get 7/4, and 1 over 7/4 is 4/7. So if you kept adding these up, it would get closer and closer and closer to approaching 4/7. So keeping in mind when this works is when the R value is less than 1 and when it is geometric and going to infinity. All right, a pendulum that is released to swing travels 18 inches on its first swing. So that right to there tells me my first term is 18. On each successive swing, the pendulum travels 80% of the distance. So that tells me my R value is 0.80 because that's 80% as a decimal, which that is a geometric sequence. And they want to know the total distance that the pendulum swings. So basically, at first it swings 18, and then you do 18 times 80%, that's 14.4. And then you do 14.4 times 80%, 0.8, which is 11.52, and so on. So when we add those all up, that's a geometric sequence. So I can do the first term divided by 1 minus the common ratio. And I can just put that in my calculator. I use a fraction button to do it. And I get 90. So that means that the pendulum, when you add up all the swings, it will approach 90 inches of how far it actually traveled between all of the swings. Okay, and this is also helpful to explain how repeating fractions or repeating decimals work, how to write them as a fraction. So I know there's some tricks to them, but we want to see how it works with this formula. So here's what's going on here. When you have a repeating decimal, it's like 0.24 plus 0.0024, that's this part, plus 0.4 zeros and then 24, and so on. So what's happening here is the first term is 0.24, the part before it repeats. The R value is 0.01. And honestly, how I remember that is I see that since there are 2 decimals here before it repeats, that's going to be 0.01. If there is 1 decimal, we would just use 0.1. If it's 2 decimals before it repeats, 0.01. 3 decimals, 0.001. And you can just try it out. If you take 0.24 times 0.01 in a calculator just to check it, then it gets that your next term is 0.0024, which is that term. Okay, so how we can write this is we write the first term over 1 minus the common ratio. So I get 0.24 over 0.99, which I can just put in my calculator. And then I can hit the math fraction button, and I get 8 over 33. And that's because this makes 24 over 99, which both are divisible by 3, which gives you 8 over 33. So if you put 8 divided by 33 in your calculator, it should be 0.24 repeating. If you want to see another one of those, look right here. This is 0.5 plus 0.05 plus 0.005, and so on. So the first term is 0.5, and the common ratio is 0.1. Remember how I told you if there's just one number repeating, then we have, okay, one decimal place is repeating, use 0.1 right here. All right, so now I just go ahead and I plug into my formula. So I have the first term over 1 minus the common ratio. So I get 0.5 over 0.9, which is the same as 5/9, which if you type in your calculator, you're going to see is 0.555 repeating.